So welcome to lesson number 3, reflection 2. We're now at the second part of that lesson, where we're going to look at mirror problems using the mirror formula. Let's go to that part of our notes. So in your table book, you have this mirror formula, 1 over u plus 1 over v is equal to 1 over f. I want you to highlight that in your table book. It's on page 16 in your table book. There's another formula I also want you to highlight. It's m is equal to v divided by u. So we'll talk about them as we go through the class. So let me look at a concave mirror. So there's my concave mirror. There's all the usual stuff, your focus, your center of curvature, your pole. Let's say I put an object outside the center of curvature. So there's my object, O. I'm not going to draw the ray diagram here. We've already done it. When the object is outside C, you know where the image ends up. You end up getting a diminished image somewhere between C and F. So there's my image, I. Now I'm going to give you a mirror formula. I'm not going to prove it for you. It's not that hard to prove, but we're not going to bother proving it here. You don't need it for the leaving cert. There are 3 numbers that I want. The first thing I want is the object distance, the distance of the object to the mirror. And the mirror is curved, so I'm talking about a tangent to the mirror at its pole. So if I take that distance there is called the object distance. And the object distance we are going to represent by the letter U. So U stands for object distance. What units will I measure it in? Meters, centimeters? Well, actually, most problems are in centimeters. So if they're in centimeters, leave everything in centimeters. That'll be fine. And your answer will be in centimeters. What about the image? There's my image there. The distance of the image, I, to the mirror is called the image distance. And we'll represent that by the letter little v. So V stands for image distance. The last number I need is the distance of the focus. The focus is big F, but the actual distance from F, the focus, to the mirror, that's called little f. It's the focal distance. We actually call the focal length. So F stands for the focal length. Now, as I said, I'm not going to prove the formula, but the relationship between those 3 letters is called the mirror formula, and it's 1 over U plus 1 over V is equal to 1 over F. So you will be using that primarily in this part of the lesson. There is another formula called the magnification formula, M. So M stands for the magnification. Now, what the magnification tells you is how big the image is compared to the object. For example, if they were exactly the same size, then I would say that M was equal to 1. That means same size. However, if the image was bigger than the object, let's say it was twice as big, then you would say that, for example, M is equal to 2. That would represent a magnified image. But then if I was talking about the image being smaller, for example, the image being 1/3 of the size of the object, then I would have M is equal to 1/3. And that would represent a diminished image. So if M is 1, same size. If M is bigger than 1, the image is magnified, and if it's less than 1, then you're talking about a diminished image. There's another formula there for magnification. So we have 2 formulae for magnification. The main one is m is equal to v over u. Again, we're not going to prove it. So the magnification m is v over u. Well, we have another formula that compares the heights. So, for example, you could talk about the height of the object. The height of the object I'll call HO. And the height of the image I would call HI. So the magnification could also be, how does the height of the object compare to the height of the image? So I can write down that the magnification m is equal to HI divided by HO. Yeah, that makes sense, doesn't it? If the image is twice the size of the object, HI over HO will be equal to 2. That formula, by the way, is not in the table book, but it's really a common sense formula. Anything else I need to know? Well, sometimes you need to know this. You see this thing called OR? You know what OR stands for? Well, we have the center of curvature, so the radius of curvature will be OR. And the value of OR is twice the focal length. Just keep that in mind sometimes. Now, the last thing we need to know before we get on and do problems is what's called the sign convention. This is crucially important. You've got to get the signs right. And the way we talk about it is, real is positive. And real is anything in front of the mirror. That's real. We'll make that positive. Virtual, on the other hand, that's negative. And negative is anything behind the mirror. Thinking about that now, concave mirrors have a focus in front of the mirror. They have a positive focus. Whereas convex mirrors have a negative focus because you know the focus is behind the mirror. So the signs are the most important thing you do when you do these problems. Let's have a look at example 1. First of all, what kind of mirror are we dealing with? We're dealing with a concave mirror. It's got a focal length of 10 centimeters. That's going to be plus 10 because in a concave mirror, the focus is in front of the mirror. It's a real focus. The object has a height of 3 centimeters. And in part A, it's placed 25 centimeters from the mirror. That is your object distance. What are they asking me to find? The position of the image, that's V. Its magnification, that's M. The height of the image. They want to know the nature. You know what's meant by the nature. Is it real, diminished, that type of thing? And they want me to draw a ray diagram to illustrate the situation. So let's put down my information. Well, first of all, what is my formula? The mirror formula is 1 over U plus 1 over V is equal to 1 over F. I've also got my magnification formula. M is equal to V divided by U. What information am I given for part A? Well, first of all, I'm told that the focal length F is 10 centimeters. And of course, that's plus 10. I'm also told that the height of the object is 3 centimeters. I'm told in part A that it's placed 25 centimeters from the mirror. And I'm asked to find V, the image distance. And I'm asked to find M, the magnification. And I'm asked to find the height of the image, HI. That's what I'm asked to do. Well, let's start by putting in to the mirror formula my information. 1 over U is 1 over 25. plus 1 over v, and that's equal to 1 over f, which is 1 over 10. Now, you can use your calculator if you wish to solve that. But when the numbers are simple enough, I would try and do it manually. So the way I'm going to solve that is by getting rid of all the fractions. I'm going to multiply right across by some term that will get rid of all the fractions. So ask yourself, what does 25, v, and 10 all divide into? They all divide into 50v. So multiply 50v by 1 over 25, and I get 2v. 50v over v is 50. 50v over 10 is 5v. Bring my v's to the right-hand side, and I get 5v minus 2v is 3v, is equal to 50. So therefore my answer is v is 50 thirds centimeters. If you want to work that out as a decimal, that's about 16.7 centimeters. So that's the image distance. Next, I'm asked for the magnification. Here's my magnification formula. Replace v and u by their values. So v, I'll use the fractional way of doing it because I had to round that off. So if I want super accuracy, I'll use 50 thirds. Divided by u, which is 25. Calculator head, I'll do that in my head. I get an answer of 2 thirds. The 2 thirds means less than 1. That means my image is going to be diminished. They're asking me to find the height of the image. I could use that formula I gave you. We can just use a bit of common sense, which I kind of prefer, because that formula is not in your table book. So the height of the image is, well, if the magnification is 2 thirds, that means the height of the image is 2 thirds the height of the object. The height of the object is 3. So we're talking about 2 thirds of 3. So that will give me an answer of 2 centimeters. They're now asking me to find the nature. Now, the nature comes in 3 parts. The first part is it real or is it virtual? Well, the way you know that from the maths is this. Look at your value of v. V ended up being positive. That means the image is in front of the mirror. In front is real. So it's a real image. Next part, is it magnified or diminished? Well, look at the magnification number. If it's less than 1, if its absolute value is less than 1, then it's diminished. And finally, the last part is it inverted or upright? Well, you know that from the first part. All real images are inverted. So they're connected. If that was virtual, that would be upright. If that's real, that's inverted. So they are connected. So that's the nature of my image. And then the last thing they're asking me to do is they're asking me to draw a ray diagram of it. Like we solved that problem mathematically. We can now solve it using ray diagrams. So here's my diagram. F is 10 centimeters. You've got the diagrams, do this yourselves, as you can do it with me. That's the center of curvature. It's 20 centimeters. The radius of curvature is twice the focal length. The object is placed 25 centimeters, so to scale, it's about there. So now what I want to do is I want to draw that ray diagram. So take rays of light coming from the tip of the arrow. The first one you'll always take is a ray of light parallel to the principal axis. What happens to it? It gets reflected down through the focus. What's my next ray of light? From the tip of the arrow through the focus. Where will it go? It'll go out parallel to the principal axis. Where do these two meet? Well, the tip of the arrow finishes here. And all the other points, if I did it, will go all the way back to the principal axis. So there's my image I. Does it look right? Well, what answer did you get for the image distance? You got 16.7 centimeters. Yeah, that looks about right. You were also told that it was diminished by 2/3. Yeah, that looks to be about 2/3 the size of the object. So everything fits very, very nicely together. So let's move on to part B. So in part B, the only difference in part B is we're now going to move the object to 5 centimeters away from the concave mirror. That's the only change. So we're now on to part B. The mirror is still the same, so its focal length is the same. What I'm changing is the U. I'm actually putting it inside the focus, and you should have some idea from drawing the previous diagrams what happens when you put it inside the focus. So let's go ahead and do the same thing again. So let's use my mirror formula. Replace U by its value of 5. V I'm asked to find. 1/f is 1/10. So multiply right across by something. That will get rid of all the fractions. 5v and 10. They'll all divide into 10v. So multiply 10v by 1/5, and I get 2v. 10v by 1/v is 10. And 10v by 1/10 is v. Bring my v's to the left-hand side. 2v minus v will give me v. Jump the 10 to the right, and you get minus 10 centimeters. The minus being very significant. The magnification? The magnification is v over u. Some teachers get you to take the absolute value of that. Personally, I prefer not to. Let's just put our numbers in. V is minus 10 divided by u, and my value of u is 5. And I get a magnification of minus 2. Now, the minus 2, just ignore the minus. Just take the absolute value of it in your head. The 2 means that the image is twice as big as the object, but the minus means it's virtual. That's what I want you to keep in mind. So in your head, the absolute value of that is 2. Image is twice the size, but the minus implies it's a virtual image. What about the height of the image? Well, what did I say? The magnification is twice 2 times the size of the object. It's going to be 2 by 3 centimeters, giving me 6 centimeters. You won't put a minus there because height would be a positive value. We now want to find the nature of the image from that information. So the first part is it real or virtual? How do I know that? Look at your sign of V. V is minus 10. That means 10 centimeters behind the mirror. So that's virtual. Is it magnified or diminished? Well, the absolute value of that is 2. 2 is bigger than 1. So you're talking about having a magnified image. And is it upright or inverted? Well, if it's virtual, that means we're talking about an upright image. They're always connected, aren't they? If you know the first one, you will know the third one. Finally, they're asking me to draw a ray diagram of that situation. So, here's my ray diagram. There's my concave mirror again. And I'm going to put the object 5 centimeters from the mirror. That's inside the focus. So here's my object. O at 5 centimeters from the mirror. So let's do my ray diagrams again. So what's the usual procedure? From the tip of the arrow, take a ray of light parallel to the principal axis. Where does it go? It's reflected down through the focus. What about my second ray of light? Well, I can't take it from the tip of the arrow through the focus because it'll miss the mirror. So my third ray of light is straight at the mirror. And straight at the mirror means, lie between C and there. That's straight at the mirror. You can see those two rays of light are diverging. They're never going to meet. So if I had someone's eye there, in their mind's eye, they will work them back from where they came. So they will work these rays of light back. And these two rays of light, they'll meet to the right of the mirror. The tip of the arrow finishes up here. I'll just extend my principal axis back, and all the other points will go down there. I'll show a broken line. The broken line means that it's a virtual image, not a real image. Is that in accordance with our mathematical treatment? Well, the image is 10 behind. That's 10 behind. If you did it on graph paper, which you guys are doing, it'd be a lot more accurate than me. And the image should be twice the size of the object. Yeah, that looks about right. And it's virtual. So they do match up with the maths. So we have one way of doing it is using the maths, and the other way of doing our analysis is by a ray diagram. Let's move on to example 2 in your notes. First of all, we're talking about a convex mirror. That's important. So what's important about that? Well, the focus is behind the mirror. So the focal length will be negative. So we're told the focal length is 12 centimeters. You have to write down mathematically f is equal to minus 12. It produces an image 4 centimeters from the mirror. They're giving me the image distance. Now, you've already drawn the ray diagram for a convex mirror. There was only one ray diagram. And every time you drew it, no matter where the object is, you'll always end up with a virtual image. So this is kind of simple. V is equal to minus 4 centimeters. You have to know that about convex mirrors. What are they asking me? How far from the mirror is the object? That's the object distance. And finally, what is the magnification? Okay, so let me write down my numbers. Well, I'm told that the focal length f is equal to minus 12 because it's a convex mirror. It might be no harm when you're doing the question to write down convex mirror. You're fully aware of that. You're told that the image distance is 4 centimeters. It doesn't say behind or in front, but it has to be behind because that's the only kind of image that you get in a convex mirror. So f is, or v should I say, is equal to minus 4 centimeters. And they're asking me to find u, the object distance, and m, the magnification. So write down your mirror formula. 1 over u plus 1 over v is equal to 1 over f. Put my numbers in. 1 over u we're looking for. 1 over v, that's 1 over minus 4. You can throw the minus in front of the fraction. Is equal to 1 over f, 1 over minus 12, which is minus 1/12. So once again, how will I solve that? Well, multiply right across by something. That will get rid of all the fractions. What does u, 4, and 12 divide into? They all divide into 12u. So multiply by 12u. So u to 12u is 12 times. Minus 4 to 12u is 3u. Equals 12 into 12u is u. So it's minus u there. So bring my u's to the right-hand side. So I get minus u plus 3u gives me 2u is equal to 12. And therefore u is equal to 6 centimeters. What about the magnification? Well, the magnification m is equal to v divided by u. V is minus 4. U is 6. So I get minus 2/3. Minus 2/3 just tells me it's virtual. But if you want to write down the answer, what is the magnification? You can just write down the absolute value of it. So the magnification is 2/3 the size of the object. Finally, let's go on to the last question in this part of the lesson, example 3. Probably the hardest one they can ask you. They're saying, where must an object be placed in front of a concave mirror? And the focal length is 8 centimeters. So that is f is equal to plus 8 because it's concave and it's in front. In order to produce a real image in part A and in part B a virtual image, and both images are twice the size of the object. Okay, as I said, this is probably the most difficult one. It's not really that hard. So let me divide my problem into part A. Part A, we're talking about a real image. Part B, we're talking about a virtual image. And each of those images is twice the size of the object. In the real image, I'm going to say the magnification m is equal to plus 2 because it's real. But over here, I'm going to say the magnification is minus 2. The 2 meaning it's twice the size of the object, and the minus meaning it's virtual. F in each case is plus 8 centimeters. So I've got two formulae. I normally start off with the mirror formula, 1 over u plus 1 over v equals 1 over f. But here I think I'll start off with the other one. M is equal to v over u. You see, in this question, I've neither got v or u, but I do have m. If I replace m by its value of 2, I've got 2 is equal to v over u. Multiply both sides by u or slide the u up, and I get v is equal to 2u. Put a box around that. I don't know the value of u or v, but I do know the relationship between them. I know the image distance is twice the object distance. Let's do the same for part B. So m is v over u. M in this case is minus 2. Is v over u. That implies that v is equal to minus 2u. Put a box around that. Now let's go to my mirror formula. Let me write it down. 1 over u plus 1 over v equals 1 over f. Now, I don't know u or v, but I do know this. I know that v is equal to 2u. So instead of having two variables, two things that I don't know, I can end up with just one thing I don't know. So I'm going to write down 1 over u. I'm going to replace v by 2u, so that becomes 1 over 2u. Is equal to 1 over f, which is 1 over 8. Now I'm going to solve that for u. Well, once again, get rid of the fractions. What does u, 2u, and 8 all divide into? And the answer would be 8u. So multiply all terms by 8u. So 8u over u is 8. 2u into 8u gives me 4. And 8 into 8u gives me u. So therefore, I can see that u is equal to 12 centimeters. So I've got to place it 12 centimeters away from the mirror in order to get that situation there. Now over to the virtual image, same thing again. So it's 1 over u plus 1 over v. V is minus 2u, throw the minus in front, and that's equal to 1 over 8. Multiply across by 8u. I end up getting 8 minus 4 is equal to u, and therefore u is equal to 4 centimeters. So in order to get a virtual image, u has to be 4 centimeters from the mirror. That kind of makes sense, doesn't it? F is 8, so I'm inside the focus in order to get a virtual image, and in part A, I'm outside the focus in order to get a real image. That works out just about fine. Okay, so we're just about finished now. Now it's over to you. Before you go on to the next lesson, you do the numerical problems. So I've shown you 3 nice examples containing all the techniques that you need. There's other little questions in here at the end of the chapter that have a little twist in them. Number 17 is very interesting. Number 16 is interesting. Number 15 is interesting. So there's some interesting questions in there. So I want you guys to work away, do those 17 questions. That's a really good workout. You've got all the answers to the questions there, and then you're ready to move on to the next lesson. Okay? So well done, and I'll see you in the next lesson.